Around 1870, a new form of technology was developed that led to further advancements of atomic theory. This was a cathode ray tube, or a Crookes tube. This device is simply an evacuated tube, meaning all the gas was removed, with a cathode on one end and an anode on the other end. This picture shows a cathode tube. When the tube is connected to a power supply, a beam was noticed. This beam had to be explained. The device is called a cathode ray tube for a reason. Why do you think? Do the beams go to the cathode or come from the cathode? Well, it is because the beam comes from the cathode. So follow this logic. The cathode is made of metal. Metals are composed of atoms. The cathode rays must come from atoms. This hints at the existence of smaller pieces of matter. J.J. Thomson used cathode rays to learn more about atoms. Okay, to recap that video, these are the observations made by J.J. Thomson and the inferences that could be made from those observations. A beam of cathode rays is bent by electric and magnetic fields. Cathode rays are emitted by any type of metal, and the charge-to-mass ratio of a cathode ray is listed there at the bottom. Okay? The inferences drawn from the observations were that cathode rays were not a form of electromagnetic radiation. Electromagnetic radiation cannot be deflected by a magnetic field. He proved that cathode rays were a beam of negatively charged particles. Because the charge-to-mass ratio was so large, he also assumed that the charge on a cathode ray was much, much bigger than its mass. The biggest inference Thomson made was that the mass of the cathode rays was so much smaller than the mass of the smallest known element. So cathode rays had to be parts of atoms. We know cathode rays as electrons. Thomson's contribution include the discovery of the electron, determining the charge-to-mass ratio of the electron, and developing a new atomic model, the Plum pudding model. Now, backing up to that second one, he wanted to determine just the charge or just the mass of the electron, but he didn't have the technology to be able to do that. So, what did his model look like? Well, something like this picture here. The atom is still a sphere with negatively charged electrons embedded into a positively charged mass. Electrons were the plums, and the positive mass was the pudding. The atom had equal amounts of positive and negative charge because Thomson knew the atom was neutral overall. Since the electrons were so small, virtually massless, he proposed that the positive stuff made up most of the mass of the atom. What were Thomson's limitations? Many scientists argued that Thomson lacked the appropriate amount of data to propose a model. But isn't this how science works? Courageous creativity. Another limitation was that he didn't explain what the positively charged material was. He explained its characteristics, but wasn't able to clearly identify it. Finally, his model could not explain the existence of spectral lines that were emitted when an atom is excited. This is something we will discuss shortly. Thomson was trying to determine the charge on an electron, but he was never able to do so. This discovery is credited to Robert Millikan. He conducted what is known as the oil drop experiment, which is summarized in the following video. So the two major findings of Millikan's oil drop experiment were that the charge seems to come in whole number multiples of a fundamental amount, 1.6 times 10 to the negative 19th coulombs in this case. These small whole numbers are referred to as quanta. We will talk more about quanta in a second. The second finding was the amount of charge on an electron, which was the fundamental amount of 1.6 times 10 to the negative 19th coulombs. When combined, the meaning of these two findings is clear. When we say an electron has a charge of negative 1, we really mean that the electron has one fundamental unit of charge, or negative 1.6 times 10 to the negative 19th coulombs. If we have an ion with a charge of positive 2, we really mean it has two fundamental units of charge, 2 times 1.6 times 10 to the negative 19th coulombs. The same result occurs with a charge of 3, so on and so forth. Quanta is the idea of small whole number multiples of a fundamental value.